All right, here we have section 1.5, solving absolute value inequalities. It is very similar to solving absolute value equations, except of course now we have an inequality. So if we have the absolute value of ax plus b is less than c, sorry about that, when c is greater than 0. Of course, c can't be less than 0 because then this would not be true. But if we have an absolute value less than c, that means we have an and. So we have, when we split it into two equations or two inequalities, we have ax plus b is less than c and ax plus b is greater than negative c. Make sure you make note of the fact that we changed the inequality symbol and we put a negative there. Okay, so on the other hand, if we have the absolute value of ax plus b is greater than c, when c is bigger than 0, if it's greater than c, it is an or. So these are things that you need to really make note of whenever you are whenever you're working these problems. Whenever you're making your notes, make sure this is a very, very important page that you keep handy. So ax plus b is greater than c, or ax plus b is less than negative c. So, yet again, we start off with greater than. We have greater than on our first equation or inequality, and on the second one we change it to less than and we put the negative. Now, these can be greater than or equal to, less than equal to. All of these apply. It's just the majority of it is going to be less than equal to here, greater than or equal to here. So let's go ahead and look at example 1. Solve each inequality, graph each solution if possible. So if we are starting with the absolute value of x plus 7 less than or equal to 2. Well, going back, if we have less than, it is what? And or. Well, looking right here, less than is and. So we're going to write our two inequalities. We have x plus 7 is less than or equal to 2, and x plus 7 is greater than or equal than negative 2. Okay, now just solve these like normal equations or normal inequalities. First step here is to subtract 7 from both sides. The 7s will cancel, and we get x is less than or equal to negative 5. We have our and here. And then on the right side, we are still going to subtract 7 from both sides. The 7s will still cancel. And we get x is greater than or equal to negative 9. Now then, whenever we graph this, we are going to put it on a number line, just like we did previously, but we have inequalities now, not just coordinates. So we're going to be shading. Now, just like before, your negative number needs to be on the left. So here we are with our negative 9 on the left. And I said your negative number is on the left. They're both negative. Your more negative number, the number that is the most negative, is on the left. So that's negative 9. The next negative number that's more positive is negative 5. So the smallest negative is going to be on the left. Okay, so now we're going to graph this. If I look at x is less than or equal to negative 5, well, since there's an equal to, I'm going to have a solid dot right here on negative 5, and less than makes it shade to the left. So I'm making sure I go to the left of negative 5. Now I'm not going to go all the way past 9 just because I don't know what's going to happen here. But now let's look at the negative 9. It says x is greater than or equal to negative 9. So greater than goes to the right and it's equal to. So that means I'm going to have a closed circle on negative 9 and it's shading to the right. Well, if we look, they match up. So now, since they match up, we have to write our answer a little differently. We're going to start with that number on the left, the -9. And we have an x and we have a -5. Notice I left some spaces there. That's for our inequalities. That's going to be less than or equal to and less than or equal to. Remember, when you have an and statement, it's all written together like this. Your symbols here and here are always, okay, almost always going to be less than on both. They're solid dots, so they are equal to's. Now then, here's your full answer. Make sure that is all highlighted. Also, make sure when you're shading, use the squiggly line. That way there is no question whatsoever as to where your shading is. All right, let's look at another one of these. If I have the absolute value of of 8x minus 11 is less than 0. Well, first of all, we said before that absolute value must be positive. So let's make a note over here in the margin that the absolute value of x, or the absolute value of anything, cannot be less than 0. So if that cannot be less than 0 or negative, then our whole answer here must be no solution. So make sure you pay close attention to that. Okay, moving on. We may come back and get some of these extra problems. For right now, we're going to go ahead and skip past them. To example 2. So solve each inequality, graph each solution. Same basic thing, but now you notice we have a greater than. So when we split this, we have c minus 1 is greater than or equal to 5. Since it's greater than, this time, we have an or. That looks a little silly. There we go. So if this is an or, then we now have c minus 1 is less than or equal to -5. So again, just make sure when this is greater than here, you have an or right there. That's going to make a big difference in your answer. All right, now then, go ahead and solve. Solve the first one, add 1 to both sides. Cancel, and c is greater than or equal to 6. On the right side over here, add 1 to both sides. Cancel, and c is less than or equal to -4. Now remember, you have an or right there. So let's draw our number line. Your smallest number goes on the left, so that -4 is going to go on the left. Largest number goes on the right, that's the 6. So if we look at the 6, the 6 is greater than or equal to, so there's going to be a closed circle on 6. And it's greater than, so it shades to the right. So we're going to shade all the way to the right there and make a bigger arrow with my shading. All right, now then, let's go to the -4. C is less than or equal to -4. Less than shades to the left. And so there's a solid dot on -4, and it shades to the left. So there we go. That is our answer. We do not have to rewrite anything, so we're just going to highlight it all. Make sure you are using a color of highlighter that you can read through. So whenever we go to grade your assignments, if we cannot read through your highlighter, if it's more like a marker, you may not want to use that. You want your paper to be easily readable, because when I go through to grade, or I go through to check what you've graded, we want to make sure that everything is correct. All right, let's look at another one of these. I have the absolute value of 10 minus m is greater than or equal to negative 2. So, can an absolute value be greater than or equal to a negative? And the answer is yes, but we've said before that an absolute value cannot be less than a negative. So if it's less than a negative, we made a note earlier that it's no solution. Or less than 0, it's no solution. But greater than a negative, the key fact there is that it is always greater than a negative. So we're going to make a note here. Since the absolute value of 10 minus m must be greater than or equal to 0, it will always be greater than or equal to negative 2. So with that, since it's always greater than a negative, our answer here is all real numbers. Okay, and the way we graph that, because we can't graph no solution, we can graph all real numbers. So we are going to put a negative 2 over here, we're going to put a 0 over here, and we are actually going to shade everything. So don't make it look like you're marking it out, but you definitely want to make it appear, or let it be known that you are shading the entire graph. So there we go. That's all real numbers, because it is always greater than a negative. It's a little easier for you to highlight on your paper than it is for me to highlight on this. Because sometimes it disappears. Okay. Now, let's just make another little side note over here to the side. If we have less than a negative or less than or equal to a negative, it comes out to be no solution. But if we have greater than a negative or greater than or equal to a negative, it is all real numbers. So that little symbol there, if you're not aware, is the symbol for all real numbers. So just a couple of little notes there for you to refer back to. All right, here's another that we are going to look at. This one has a little bit more involved with it. So remember the assignment that we had the other day? You were having a little trouble, some of you were having a little trouble with solving problems like this. You must, and if you need to go back and watch your other video, feel free, you must get this absolute value by itself first. So all of the stuff right here, you have to isolate it before you can do anything else. So to isolate that, we are going to subtract 1 first. So when solving, you need to add or subtract first. And we're going to get 4 times the absolute value of 2x minus 5, and that is greater than 20. Now we need to, that's 4 times the absolute value, so we're going to divide by 4 on both sides. And we come out with the absolute value of 2x minus 5 is greater than 5. So here we go. We have an absolute value that's greater than. That greater than right there means that we are going to have what? An and or an or? Well, if you go back to that one of those first pages you wrote down, it's going to show you that it's greater than, so this is an or problem. So now we're going to split everything up. We have 2x minus 5 is greater than 5, so we just dropped the bars. Now we're going to drop the bars, 2x minus 5, change the sign to less than, and change it to negative 5 on the end. Now then, let's go ahead and solve each of these. So we're going to add 5 to both sides. We have now 2x is greater than 10. And if we divide by 2 on both sides, then we get x is greater than 5. Or, go ahead and go over to the right side. We're still going to add 5 to both sides. The 5's will cancel. We have 2x is less than negative 5 plus 5 cancels, so that's 0. Now you're going to divide by 2 on both sides. And x is less than 0. So now go ahead and graph that. Draw your number line. The smallest number goes on the left, which is going to be our 0. The largest number goes on the right, which is our 5. So then if we go back up here and look at the 5, it says x is greater than 5, greater than shades to the right. So 5 is going to have an open circle because it's just greater than, and it's shading to the right. Okay, now if we look at 0, x is less than 0, so less than's to the left. It's just less than, so we have an open circle on 0, and we shade to the left. And there we go. Go ahead and highlight your answer. Alrighty. Now moving on. We're going to skip over that. Okay, this right here is going to be just a little bit more involved. Okay, sorry. It's a little bit more involved. We're talking about absolute deviation here. And so you are buying a new computer. The table shows the prices of computers in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? Well, to do that, we're going to have a formula here, and our formula is that we have the absolute value of x minus our given is, and I'm going to put equal because it's all going to depend on what it says in the problem. This one says at most, so that tells us our sign, but that's equal to our absolute deviation. Abbreviating those, and it'll tell you your absolute deviation in the problem. All right, so if we follow along with that, then we have our formula here that we are going to rewrite. That is the absolute value of x minus the given. And that's equal to the absolute deviation. Now we are going to fix this or alter this as we go through. So the given, well, it says you are willing to pay the mean price in this one. Mean means average. So we're going to go up here, and for this problem, we're changing this given to average. So to find the average, we're going to have the absolute value of x minus, well, the average is going to be the total divided by the number of places or prices. So let me scroll up so you can see them all. Let me finish my equation here. And that's, now, when we have this, our x minus the total divided by the number of them, we have equal. Well, right here it says at most. So at most is actually meaning less than or equal to, and that's where our 100 comes in. We want it to be less than or equal to 100. So let's go ahead and find that. If we were to add all of those up, and you can use your calculator if you would like. I'm not going to make you do that all by hand, but our total right there is going to be 6,640. And then if we count how many there are, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's fill that in here. X minus 6,640 divided by 10 is less than or equal to 100. All right, so go ahead and divide that out. Well, really, shortcut there is to knock off those zeros. And now we have absolute value of x minus 664 less than or equal to 100. So we have an equation now to figure out our numbers, because it says how many of the computer prices meet your condition. We are going to have to solve that equation. So in this problem, not only are we having to make our own equation, but we're having to solve it as well. So let's scoot on down here, and we're going to split this off. We have x minus 664 is less than or equal to 100. This is less than, so it is an and problem. And then we have x minus 664 is greater than or equal to negative 100. Now we just need to solve these two equations. Add 664 to both sides. So then when we do that, x is less than or equal to 764. On the right side, we are going to add 664 to both sides. And now x is greater than or equal to, well, that's negative 100, and then 664, so that's going to give us 564. All right, so if I were to put that together, there's an and there, then it would be written as 564 less than or equal to x less than or equal to 764, because it's an and, it's written together like this. So we're going to now go back and find all of our prices that are between 564 and 764. So I think we have all of them in view now. So let's highlight and mark off, or we can circle either way. So 564 to 764. 890 is too big. 750 works. 650 works. 370 is too small. 450 is too small. 670 works. 725 works. 650 works. 660 works. And then 825 is too small. I'm sorry, too large, too large. So if it says in the question, how many of the computer prices meet your condition? Well, let's count up. We have 1, 2, 3, 4, 5, 6. So we have 6 prices. And I'm going to go ahead and list them out. That is going to be 650, 725, 660, 750, 670, and 650 again. Okay, Yep, that's all of them. All right, so that is actually our answer. Very multi-step problem. I know it's very long because it's a word problem, but you've written those inequalities, or actually those equations, before. That's similar to the cheerleader problem from section 4. And so now we just added in the fact that there was an absolute deviation and making it an inequality. And that's going to be it. This video is just a little bit shorter than the rest, or than the last two at least. So there we go. We're all done with section 1.5.